Hello everybody, welcome back to the workshop. Fairly warm out here today, so I'll make this introduction quick. Today we're going to be making a saw stand with a roller on the top. It's going to look very much like this. You can see it up here, nice and smooth and even. This was just made from bits and pieces I had lying around the workshop, offcuts from previous jobs, you name it, I've used it. So if you want to see how I made this from a saw, keep watching. I've gone digging through my junk and I was looking for a couple of bearings, and I found a couple of bearings on the end of this little shaft. It used to be the spindle out of a bench grinder. It was given to me a while back, and I thought, what am I going to do with that? So I filed it away, and sure enough, now I've got an idea for it. If I get this little bit of tube here and turn down the inside of that rotor there, I'll be able to fit the tube onto the spindle and make a couple of little bushes to hold those two bearings in that diameter. Currently they're too small, or the tube is too big, and that'll make a pretty good size roller. And with a couple of these bits of bent tube that I was going to throw away but didn't, and this one will go inside there like that. I'll be able to weld a nut on the outside. That'll make my height adjustable. I'll be able to weld that in there somehow. Wait till you see my welding skills. And I reckon I'll be able to make a little roller stand. This shaft has already got a centre in both ends, so that makes it easy to sort that out. Just a standard high-speed steel turning tool in there, nothing fancy. Not sure whether this is going to vibrate and make horrible sounds, but let's find out. I don't know whether you can see it there, not quite. This dial here is graduated in inches, as I said. It's 1/100th thou per turn, so 1 turn is 100th thou off the radius, but that'll take 200th thou off the diameter. So I basically need to go 1 turn. Not critical, all I need to do is clear the inside of the pipe. I'll just touch it off there. Set my little graduations here to 0. Let's take off 10 thou and see whether it complains too much. Actually, I've got the feed disengaged. I'll just re-engage that. If you really want to see that, I'll show you. Let's try that again. Try a bit heavier cut, another 10 thou. You can see how much it springs out of the way. When I wind it back, the tool will drag. I've moved the tool in 50 thou. That's just the tool, and that will take 100 thou off the diameter, and I've got about 100 thou to go as expected. On track. Another 15. Let's just check our size. It's exactly 1 inch and 600 thou. So that'll do the job. We want it to confirm it's going to fit. We'll just take our centre out the way. Now it goes over. Just to be nice, so I don't cut myself while I'm assembling it, I'll just grab my little chamfering tool. I think I've done a previous video on how I ground that up and what the angles mean. Don't want any crap in the dovetail there. Put our tailstock back in. Oops, too close. Looks like the end of this is aluminium. It's nice and soft. Now I won't cut myself on that sharp edge while I'm dicking around with it. I think that's all I need to do to that piece. I will take that out. Doesn't look too bad. As I said, it's not going to matter because it's going to be hidden inside that tube and never to be seen again. The next bloke that pulls it apart will be surprised that it's in there. Now, the ends of my tube here are just sawn off and they're probably skew-if and crooked. Let's stick that in. I can stick it in the chuck, but it's going to be sticking out way too far to do anything with. This lathe's got a fixed steady that I can use. It's a bit small, but so is everything on this machine. That's it. There's no rollers on it. It's just got little brass legs that will touch against here. Hopefully that's round enough for the job. Let's set that up and see what happens. Again, not essential, but we're here now. We may as well do it properly. I'll just set that to a nice slow speed. I'll just pop this belt here down onto the slowest, or the second slowest one, see how we go from there. That's alright. You might be able to see it's running out a bit. Let's just see if I can donk it with a hammer and screw that up so I can set my steady. If I don't get my steady in the middle, you can actually walk the piece of tube out of the chuck. You don't want that to happen. just doing that to it, just touching on the metal with the screw, has centered it up. So I'll just touch that again. And the one at the back. We'll just stick our turning tool back in there again. We can face off the barrel, face off the end of the tube. Just give it a bit more side clearance there. Put my glasses back on. That's got that cleaned up. Now I'll just take the burr off again. And the trouble is now my chamfering tool is facing the wrong way. Before I was coming in this way, now I want to come in this way. Just a touch to take the sharp edge off so I don't cut myself. Just got my hand scraper here, just to take the last little bit of burr out in there. There we go. This steady is not hinged, so I can't just undo one side and hinge it out the way. I'll have to take the top one off and slide it out. That's probably because I didn't take the rust off on this end. What the hell? I'll polish it up in a minute. Alrighty, I'll just give that a bit of a polish with emery cloth now so that it looks nice. Or in my case a bit of coarse wet and dry. Maybe a couple of speeds faster. I could dick around trying to hold it some fancy way. I think this will do the trick. There we go. You can see that. That now looks reasonably consistent along there. And now we can start making the plugs for the end. I've never been one for winging it when I make stuff, so I always find it's good to make a little sketch, and so that way you can write your dimensions down, you're not remeasuring stuff and you know where you're going. Basically what I'm doing now is this bit of tube, 250 millimeters long, and there's my dimension up here. What I want to do is end up with this piece mounted inside there, about equal distance in the middle. The only part that touches the tube will be the bearings, and the axle itself will spin freely. So what I've come up with, I'm going to make two bushes, one for this end, one for that end. The outside diameter of the step here will fit the outside diameter of my bearing. The inside hole here will just be clearance on the biggest diameter there, which is, Dave puts glasses on. That's just under 15 millimeters. So I'll give myself a bit of clearance. We'll make it 16 millimeters. I can put in 16 there. Yes, I'm left-handed. So this distance here will be the 250. Actually, I'm going to have to start calculating this distance there first. So it'll be 250 minus 160 divided by 2. Don't be afraid to use a calculator. I wonder if my calculator still works. No charge. Please stand by. Don't worry, had to use my Brian. That didn't come good, but I'll leave it on the charge. So 250 minus 160 is 90, and 90 divided by 2 is 45, there and there. So if I add 45 and 11, that makes 56. So the whole length of this piece will be 56. I measured the inside of my tube because I want this bush to be a light press fit in there, and that'll be 41.6 millimeters. So with all of that done, I should be able to press these lightly into the tube and encapsulate the shaft all in one go. There'll be no side load to make this roller try and come off the bearings there, so it's only going to be just rolling material in and out of the saw. So without further ado, let's get back and finish that. I've got some, I'll make these out of plastic. I've got some neoprene, nylon, not sure exactly what it is. Like that. And the big choice here is, do I make it out of red or green? Looks like the green one is longer. I'll make it out of the red one. Only because I like red. We'll just make it 60 mil long. Give us a little bit to machine off and square it up. If I was really keen, I'd set my stop, but I've only got to make 2, so I can measure 2. Probably quicker than I can set the stop. And then you can turn it on. Measure twice, cut once. Just checking I haven't got the blade in backwards. Should cut through that shit easy. plenty of room. Please stand by. Now, I could edit that out, but I know you guys like to see that stuff. Don't like pretending that I never make any mistakes. Now it'll miss. I did look at that, but I didn't look closely enough, obviously. Hey, don't burn my butter. Need to adjust my stop button as well. Perfect. Alrighty, back over at the Atlas lathe. You'll notice if I wind out my jaws here big enough to fit this piece in there, I've already come out. So you have to be careful, even though it looks like that jaw is still a fair way engaged in the scroll. If it was here, it's only going to be in there by a cat's knacker, and you can break the end of your jaw off or whatever. Dangerous stuff. So what I'll do is I'll take these jaws out and put my reverse jaws in. You can't turn these around because they've got an arc cut into the teeth. You can turn around a 4-jaw chuck, usually, depending on the chuck, but you can't turn 3 jaws around. They usually come with they always come with a second set of jaws. Whether they've been lost or not over the years is hard to say. Mine haven't. So just make sure you've got no swarf and shit stuck down in there. You can blow it off with compressed air, but I don't have my compressed air on at the moment. You'll notice, usually on the inside here, these jaws are numbered. That one's got a 1 in it. That one's got a 2 in it. And that one's got a 3 in it. You have to put them in the right order, but also, if you look down in here, on this chuck, these 3 slots are numbered as well. It's best to put them back in their right slots. A lot of people say it doesn't matter, and it apparently doesn't. It'll still run reasonably true, but they wouldn't have numbered them if they didn't mean you to put them back in the right spot. So that one's got a 3 in there, that one's got a 1 in it. What you do is, you wind your scroll around till you see the first tooth come around, you can see it there, and you grab jaw number 1, plop that in there. Idiot. And then, now that's got that captured, move around to the next tooth. That one's got a 2 written in it. Turn it around till you see the scroll start. Come back a bit. Jaw number 2. Don't do it twice. And number 3. Scroll around till it see the first tooth start. Then put the third one in. Everybody's happy. Now they're all in the right positions. Anything else, that won't work. So I can't go all the way down and lock it in there, so I'll have to use the next step out, which is there. Hopefully the end of this isn't too far out of square. Let's see how that goes. I always do a quick reasonableness check to make sure nothing's going to fly out and hit me. I usually stand with my head out of the way just in case I've forgotten to do something. So it's a little bit wobbly. Not too bad. That's pretty good. We're going to be turning the outside diameter anyway. We've got nearly 20 mil. We have got 20 mil to come off there, so it's going to make a fair bit of red streamers. First thing we'll do, we'll get our turning tool back in there. turning and facing tool. We'll see if this is sharp enough to cut this stuff. Pardon me. Just give ourselves a bit of clearance either way, so I can turn and face with the same tool. The front of that tool is less than 90 degrees, so if I set it properly, I can face off with it and turn with it, and I won't interfere with anything. And you can see that. You can't really. Let me bring you around the other way. Let's see how I go on centre height with this tool. Pretty good. If it's too high, I won't be able to get to the centre because it'll rub, and if it's too low, it'll leave a knob there. Can I clean it up? Yep, that's all right. Let's turn the outside down to 41.6. Close as we can go without hitting the chuck. Might give ourselves a little bit more clearance. Let's just take 30 thou off. That'll be 30 thou on the depth of cut. That'll take 60 thou off the diameter, which is about 2 millimeters. That's close enough. I've got about 3 or 4 mil before I hit the chuck, and I'm over halfway, so I'll be able to turn it around and do the other piece from the other side. Finish is quite nice. $47. Leave alone! Flash! That's it. In the kennel. In the kennel. Now. Flash! In the kennel. Flash! Leave him alone. In the kennel, man. Where was I? check that. And for 41.6. That's what it is. I'll let that run through. Spring cut. We'll call that good. Now let's call it a day. I've got some other jobs to do around the farm, so I'll be back tomorrow. But for you, it'll be like... It's a couple of days later, and we're just going to carry on now, and we'll put a 17mm drill, I think I decided on, through the middle of that. It's only plastic, so I don't think I need to centre drill it and muck around. This is a Morse taper shank number 2, and my tailstock luckily has a Morse taper number 2 in it as well. They just lock in. Give it a couple of winds forward, about there, and that won't come out now. When you want to get them out, you just wind it back until it knocks it out, in case you wanted to know that. Put a bit of oil on my spindles. These have just got plain bearings. There's no rollers or anything in there. So you need to make sure you don't run it without oil on them. Pick the bucket. This is just a clearance hole, so it's not that, doesn't need to be accurate. If the plastic keeps coming out, I'll keep going. Whoop, out of travel. This only travels about 2 inches. 50mm. So I need to get a bit closer there, like that. Starts to pack in there too tight, we just clear it out. Don't do that with steel shavings, by the way. That's the end of my travel again, so I need to go a bit further. Go all the way through. Now I need to bore out a counter diameter in there to allow the bearing to fit in. Now that size is important. I want to make it about 34.9mm. That should give me a light press fit on the bearing. This is just a high-speed steel boring bar that I ground out of a piece of square. You don't always need fancy tools for everything. You can see that I've just grounded down here, and that gives me clearance on the side, and rounded it off, clearance underneath. Everything's good. The depth is going to be 11 millimeters. So I'll just wind my compound slide back 11 millimeters, or about that far. Wind it forward again till I get to a 0 on my scale, which is there. Now I'll touch this on my job. Just for now I'll lock the carriage. I can just slide my carriage stop up against the carriage, hence the name carriage stop. So we'll just slide that up there till it touches the carriage, and I'll nip those two up. There we go. So now that'll touch the carriage there right when the tool is at the edge of the job. Now what I do, 11 millimeters is 431 thou. So now I can wind this forward 100, 200, 300, 400. We'll go say 420. That'll leave me another 10 thou to clean up off the bottom. I want to make it 34.9, and I've now got 34.5. That'll leave 0.4 of a millimetre. 0.4 of a millimetre is 15 thou, I think. 16. So half of that will be 8 thou. And I normally do it in 2 cuts to allow for any spring, so I'll take 4 thou off, and that should leave us 4 thou more. .7, so that's another 0.2, be another 4 thou, won't it? Back against my stop, I'll give it another 5 thou. The corner there. We'll just double check our diameter. .92. So that should be an interference fit with my bearing. Now I can just put a little chamfer on those. Have to get my stop out the way. can turn it around and face that big hunk off there. It's a couple of days later. I managed to make the other one of those little spaces. I've been thinking about how I was going to do this frame, and I tried welding this stuff. It's not very thick. It's like less than 1 millimeter thick here, and it's got galvanized plating on it, or zinc plating, and I ground all the plating off on the outside, but still didn't help. Blows holes, really hard to weld, and the fact that I'm not a very good welder, I decided this wasn't going to be successful. So what I decided to do was just cut some slots, fold it up, and bolt it on. And the outsides here will get held up tight when I put the spindle of the roller in there. So these are just kind of sitting there, but that won't go anywhere. All the force is straight down anyway. So I think this will be the way to go. This bit goes up inside there, so I'll have to figure out how to mount a nut on the side here to fix the position. These two, I'll just cut a square notch out of half of one of these, so they'll go together like that, and then I'll be able to bolt that piece on top of there. I'll go ahead and do that. Alrighty, I've just deburred those two pieces, and as it turned out they were a light press fit to put them together, so I just tapped them together. That'll just make it easier to install the next bit. You don't need to have a milling machine to do that. You could have just cut down the sides with a hacksaw and gone in there with a grinder and taken it out. And this doesn't need to be that accurate, but I've got a milling machine, so I may as well use it. Next, what I'm going to do, this is the vertical mast, or piece that stands up there. I'm going to drill 4 holes. I've just marked them out in there. Not sure if you can see them. I'll center punch those in a minute, and I'll put a line down here as well. What I'll do then is cut down each of these on the diagonal and fold those pieces out to make like a cross, and that will allow me to bolt that piece directly onto there. These are the screws that I plan to use. They're like a self-drilling screw. The point of that is 4 millimeters diameter, and the thread's about 4.9, something like that. So that way they're like metal tapping screws. Forget what their actual name is. These are just some leftovers I've got kicking around. This whole thing's been made from bits and pieces I've got left kicking around. You can just bend those out and make that corner square as we can. No rocket science here. bit more pressure. I'll just give that a bit of a deburr around the corners here, then I'll mark my holes through there and I'll screw that on. I'll bring you back when that's done. So that's got a 5mm drill through the middle there, and I've just put a 3/8 slot drill which will clear the head of my screw. I think I might have lost some footage there where I forgot to push record. So now I just need to put a chamfer on here and a chamfer on the centre hole, make those tidy. Looks like my chamfering tool is facing the wrong way. Isn't that always the way? Something like that. Something like that. Get my little screw head, goes in there. So now that'll sit down in there and everybody will be happy. Alrighty, there's the other 3 of those made. They've all just got a hole in there to take one of those little screws like that, sticking out the other side. So there's 3 of those, and the 4th one I just drilled and tapped with an 8mm hole through there. I found a bit of 8mm threaded bar I had kicking around with an 8mm nut, and this is just a machine knob I had left over from a previous job. Generally when I buy stuff I buy a couple of spares. I threaded that on there, there we go, and it by luck had an 8mm hole tapped in there as well, so I didn't need to change any of that. So with that on there, do that up, I can poke that through an 8mm hole that I drilled in there and thread that on that way up. I didn't quite tap it all the way through, so I can screw it on and it comes tight about there. So now I can turn the knob and it'll just go up and down. It's got those 4 done up. Now all I need is some test concrete. In the frame. How about we zoom you in a little bit? There. So now I should be at rocks as planned. Should be able to wind that one down. Like that. What I think I might do is knock something in there so I can use that to wind it up and down, and this will just be a lock nut. My father's noise. Rightio, that's got most of the pieces made. You can see I've got this bit put together. That bit goes in there like that. Good catch. These 2 bits will go in there, on each side, and that piece goes down in the middle of there. I'll show you all assembled when I get that far, but next bit I just need something to clamp around here and lock that at the height I want. Found this piece of aluminium just kicking around in the scrap, and what I'll do is I'll turn the smaller diameter there to fit over that one, and the larger diameter fit over this one, and that should let me just plonk it on the top there, and I'll drill and tap a hole through the side, put a bolt in there, and drill a hole in the side of that, and that'll let me just sit that on the top of there and clamp it down. And I'll just turn this down to something else so it's got a reasonable thickness of thread in there. Come and watch me do that. I can't use these outside jaws because the jaws touch together in the middle, so I'll use the inside step there. I just have to watch out for these banging into my tool post or banging into me. Just thinking about how I'm going to hold it so I can turn the outside. Ideally, I'd have a mandrel made to suit that, but I don't think I can be bothered. What I might just do is chamfer both these outside edges and leave it at that. I don't need to make it smaller. It's not going to be in the way of anything. I found a bolt. That's M10. I know it's M10 because I measured it with my vernier. It's just under 10 mil. And then I found my M10 tap, M10 by 1.5, and that lines up in there. So I know I'm going to be able to drill and tap my hole so that bolt will fit. I'm just going to stick a line across here like that, roughly square. Nothing too fancy. Now all I'll do is measure 37.5 from the edge there, and that'll have that line directly in the top. As you bring it in, that'll slowly run through that, and you keep going till it just kicks off. Go. Now that diameter there is 10 mil, so I'll come out 5. One turn is 4 mil, plus another mil is 5, somewhere there behind that knob. Then the thickness of that, or half of the thickness of that, was 6.75 mil. So I wrote it down. So we go 4, 5, 6, 0.2, 0.4, 0.6, 0.75. And I can lock the table in that direction. This one's called a wobbly pointer. Need more room. It's got a ball on one end that goes inside that little chuck and a pointer on the other. So we just stick that in there, tighten her up. When we spin it, it does that. You can do this with a ruler or anything if you want. Just slowly come down to the end until we get it to run true. There we go. Like a knife's edge. So I can get that to point to my line now. Doesn't need to be super duper accurate because I was only measuring it with a ruler. Somewhere like that. Anyway, you get the idea. I always like to centre drill my holes because that's the way I was brought up. It's the next day. I've just given these parts a bit of paint just to make them look a bit nicer, and decided to leave that one unpainted. I might just rub a bit of oil on it just so it's not exposed. Now let's put it all together. The only thing you missed is I cut a slot in the top of this one here. That's so when I put that on there, the bolt can go through the slot and clamp onto the square that slides up and down the middle. So that goes on there like that. This one will go in here like this, and I can just tighten up that bolt and it'll clamp at the height that I want. Now I think if I just take these off there on both ends, one of them's left hand thread because it used to be a grinder, so that one can go on there like that. Should be a light press fit, might need a little bit of a tap. Sounds like it's all the way in there now. You can see that's nice and flush. Now I can put this one in here like that. Again, this should be a light press fit in there. The only interference will be the weld on the inside of the tube. So let's see how that goes. Probably be a bugger to get it back out again if I can't get it all the way in. Let's go over to the saw. Alrighty, here it is next to my saw, all lined up. See there's a bit of a colour scheme thing going on. I think it looks like it's meant to be there. Don't forget to like, comment and subscribe, and we'll see you on the next one. I can't really see you.